Welcome to Lesson 29, Part 1. Before we turn to the page, I want you to make sure that you have a highlighter for this lesson. So make sure you have your highlighter out along with your pencil. Okay, so we are looking at Lesson 29. In Lesson 29, explain equivalent fractions using visual models, pages 5 and 6. So let's turn over to pages 5 and 6. And here we're doing 4th grade, NF, numbers based on fractions. Numbers, operations, fractions, A1. I can explain and show models for why multiplying a numerator and a denominator by the same number does not change the value of the fraction. Language objective, I can use vocabulary related to fractions to communicate how fractions are equivalent. Social objective, I can work with others to create models to prove that certain fractions are equivalent. So we have quite a few vocabulary words here. A fraction is a partitioned share of a whole group, division of a numerator by the denominator. So we're cutting something up into pieces. A unit fraction is one equal part of the whole. The fraction has a numerator of 1. So if it's cut into 8 pieces, the unit fraction would be 1 out of 8. If it's cut into 4 pieces, the unit fraction would be 1 of the pieces out of 4. If it's cut into 100 pieces, the unit fraction would be the 1 piece out of the 100. So the numerator is always 1 because it's 1 unit of what it's cut into. Okay, numerator, the number written above the line in a fraction that shows how many equal parts of a whole or group are being considered. So like with our daily fraction, our numerator is always the day we are on. That's the part we're looking at. We could look at how many days are left. So it depends on what you want to look at, what would be the numerator. Our denominator, the number written below the line of a fraction that tells the number of equal parts in which the whole has been divided. So like for our school year, it's divided into 180 days. That is the whole amount for the school year, so that is our denominator. This is the part we're looking at, and this is the whole. The whole thing, something that has not been divided or partitioned. So if we just look at the school year, and not the individual days, that would be the whole thing, the whole year. And then we look at the pieces, that's where we get our denominator. So here are different terms for fractions. Half of, one of 2 equal parts of any whole object or group. Halves, a term to show that a whole has been partitioned or divided into 2 equal shares. So halves means cut into 2. Half of, cut into 2 equal pieces. Thirds, a term to show that a whole has been partitioned or divided into 3 equal shares. So thirds. Fourths, a term to show that a whole has been partitioned or divided into 4 equal shares. So far we have 2 ways of saying 2, 3, 4. Next we have sixths, a term to show that a whole has been partitioned or divided into 6 equal pieces. Eighths, a term to show that a whole has been partitioned or divided into 8 equal shares. And tenths, a term to show that a whole has been partitioned or divided into 10 equal shares. Alright, so here we're looking at fractions in general, and more specifically equivalent fractions. So this is where your highlighter comes in. So if I highlight one of these two pieces, I now have a total of two pieces and one shaded in. So I am representing 1/2. But I could also shade in that same amount on this one. Exactly the same part that I shaded in my first circle. Shade in this one. But this time, it's cut into more pieces. I have a total of 1, 2, 3, 4, 5, 6, 7, 8 pieces. And I have 1, 2, 3, 4 shaded in. So these are definitely different numbers than this. I have 1 and a 2, a 4 and an 8. But do I have the same exact amount represented? I do. This is half and this is half. But because this has been cut into smaller pieces, there are no more to represent that half. 4 is half of 8. So 4/8 is equivalent to 1/2. Well, let's look at this one. Do the same thing. Highlight that same area. Now we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. And we have 1, 2, 3, 4, 5 shaded in. 5 is half of 10. So this is half, this is half, this is half. These all have the same amount that's shaded. What has changed is how many pieces it's cut into and the size of the pieces. As I cut it into more pieces, those pieces become smaller, and it takes more of them to make that fraction. So instead of 2 pieces, I now have 10 because it's been cut up into smaller ones. So I have 10 pieces and 5 are shaded in. So these are all equivalent to 1/2. Now let's go ahead and look at 1/3. So I'm going to just highlight this top section here. I have 1, 2, 3 equal pieces and 1 shaded in. Well, I want to shade this exact amount on this one. So it would be this right here. That's the exact amount. See how that is the same area as this? Same amount shaded in. Well, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 total pieces. And 1, 2, 3 shaded in. Same amount is shaded in. It's just now my pieces are smaller. So 1/3 is equivalent to 3/9. These are exactly the same amount shaded. It's just that these pieces are smaller. But put together, it's equal to this. Okay, for this one, we want to shade the same area. I'm going to go straight up and then down at that angle. So same area shaded in on all 3 of these. But now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. And we have 1, 2, 3, 4 shaded in. So again, the pieces are just getting smaller. So the larger the denominator, the smaller each piece is, and the more there are of them. but I still have the same area shaded in. So 1/3 is equivalent to 3/9, which is equivalent to 4/12. These all represent equivalent fractions for 1/3. Okay, so now we're just going to look at fractions in general. Okay, and you want to use your highlighter. So this one, because we can get a large space here. I'm going to just circle in that, color in that whole circle and this whole rectangle. Because when we're looking at whole, that means we're looking at the entire thing. So I have one piece, and that one piece is shaded in. So we could write it as a fraction as 1/1, which is just the whole thing. One whole. The whole thing is shaded in. Okay, now we've cut it into two pieces, two equal pieces. Fractions need to deal with equal pieces. On some of these, they may not be precise, but they should be pretty close. So here I now have two pieces, and one shaded in. So each represents 1/2. But are these two halves equal to each other? No, because these two wholes are not equal. We couldn't say that they're equal to each other. Just the whole thing is there. The whole thing is there. Only the ones that have the same shape and size could be compared. These could be compared, but these can't to each other. So 1/2 is half or halves. Okay, next we have our thirds. So 1/3. As we cut it into more pieces, those pieces become smaller. Here we have 1/3, or 1/3, thirds. Here, I'm going to do 1/4. So each time I'm having to color less of the area because those pieces are getting smaller. These are all unit fractions too, because I'm looking at one piece, one unit of what it's cut into. So here's 1/4 or fourths. Another name for fourths is a quarter. That is why the coin is called that, because it takes 4 quarters. It's 1/4 of a dollar. Okay, so fourths or quarters. Okay. Now we're looking at 1/5. When you get the odd number of pieces, it can be harder to draw. The even numbers are a little easier. So I have 1/5, so that's fifths. Okay, we have 1/6 there. Now this is a case where the pieces didn't all end up the same size. This one's a little skinny, but they're pretty close. So we have a 1/6, which is 6. Now you may notice we don't have sevenths and ninths. We didn't have to represent all of the fractions. Sevenths are a little challenging to draw, as are ninths. So we're going to be able to get what we need based on what we have here, so that's fine. So now we're looking at 1/8. So you could still make sevenths and ninths, but that's not what our standard looks at, so we'll just stick with this. So we have 1/8 is eighths. and then last one. And then every time that denominator gets bigger, these pieces get smaller because there needs to be more pieces that fit in the same area. Okay. So our unit fraction here is 1 out of 10, which is tenths. So these are our basic fractions here. And we're going to look more at showing and explaining how they are equivalent. So let's go ahead and turn this over for part 2 and our 3-column notes.